All right, so on this one we have problem 415. We have a voltage source over here, 5 kilo ohm, 20 kilo ohm, 70 kilo ohm, 10 kilo ohm, an RL value here, which is going to equal, for this one, it's going to equal 4, which is part of the problem. And what we're asking for is find gain G equals VL over VS. So the voltage of the load over the voltage of the source. And specify linear range. Okay, so what we're going to do for this one. One, identify. This is a non-inverting amp because, again, our signal, all of this is going to go into our non-inverting, our positive. So non-inverting amp. We know it's an amp because over on this side we have our amplification, because some of it's going to come down here. We have a voltage divider between the two, so some of that voltage is going to get fed back around and some's going to get to go down. The relationship between these two lets you know how much is going down and how much is getting fed back, and that's going to be our gain equation. So that's part of it. So we have our non-inverting amp. So what we're going to do is we're going to do step 2, which is redraw. And so our normal equation that we have for non-inverting op amps is going to be positive, negative, our voltage source prime, and this one is going to come down here to this, and this is going to come down to 10, and then this one's going to come over to 70, and this is going to be our V out. So all of this stuff on this side is separate. So the way I'm looking at this problem now, let's highlight this. This chunk is 1. Okay, that's step 1 to figure out. Can I close this pen? Not really. That's going to suck. There it goes. This one is 2, and that's what 2 is here. So this is 2, and that's what this chunk is here. That's 2. And then our last bit that we've got is step 3, which is just a voltage divider. That's 3. So we're going to solve this into different pieces. So the first bit, we've redrawn this. This is part 2. We know that our gain equals, for a non-inverting amplifier, equals 1 plus R1 over R2. We got that out of any of the charts that we've had in the class or whatnot. So this is going to be our AV equals, what is this? Equals 1 plus, what's R1 in this case is going to be 70 over 10. So 7 divided by 10 equals 7 plus 1 equals gain of 8. That is our gain for this equation, is 8. So now we're going to look at Vs to V prime. So right now we have our V prime here. This is our Vs, our voltage source. So how do we get from this chunk to this? And this one is going to be 3. We need to do a voltage divider. To bring Vs to Vs prime. So again, now we've got to simplify all of this stuff in the front. So this is our pink section. I'm going to take this out again. So how do you want to circle this? I'll circle it when it's done. So our gain equation for this, V S prime equals Vs times our voltage divider, which is 20 over 5 plus 20. Standard voltage divider equation. And this is going to equal 0.8 Vs equals Vs prime. That's our equation that we're going to lock away. And again, how did this come from? This is all the pink from this first step. So this is, again, voltage divider, because we know some of the voltage is going to come into this op amp. Some is going to come down to the ground. So what is the voltage through there? Well, we have to do the voltage divider at that point. And that's what we did in this part of the equation. So there we go. And now we need our gain equation again. So V out equals gain times Vs prime, because again, this is our gain a gain of the op amp here, which is by those two resistor values, our Vs prime, which we've already solved, and then our V out, which is what we get over here, our V out. We should probably write that in, V out. Okay, and then do we call this one Vs? I think, yeah, this is all Vs coming up through here. Vs prime up there. So anyway, now we're going to look at calculating this out. So what do we have got for this? We have our gain, our A is 8, so 8, cool, times our Vs prime is 0.8, 0.8 Vs equals V out. That looks good to me, that looks good to me, that looks good to me. So V out equals 6.4 Vs. So let's box that one and save that. So that gives us our V out. So now we've gone from here with the voltage divider, here with our normal gain equation. So we got one thing out of each of these. And now we got our V out. And our V out is what we're going to use into here. And what is next part coming? It's another voltage divider. So 5. Another voltage divider. Voltage divider at output which brings V0 to VC. It's going to bring this V0 to VL, VC. Let's call VL. Keep it the same. So VL, voltage output, equals our two resistors, which are 4 and 4, over 4 plus 4. That's our normal voltage divider equation, times our V out, which is whatever this point is. So this point, some of it's going to go through here and some of it's going to come down here. That's what this equation does. And so our VL equals 4 over 8 equals 1 over 2 equals V0 over 2. We bank that equation. So now let's just double check here. We have 1, 2, 3 different variables with 1, 2, 3 equations. Do we have anything else? Actually, we have 4 variables, don't we? 1, 2, 3, and then 4. So 4 variables with 3 equations. We need one more equation that relates something from one of these, and we have it up here. It was given to us, our gain equation from the very, very beginning. So that's going to be our 6 solve gain equation. And our gain equals VL over Vs. And so if we take our VL, which is right here, so that's going to equal, our gain is going to equal V0 divided by 2 times 6.4 divided by V0. This comes from this one. Our V0s are going to cancel. We got 6.4 divided by 2, and that's going to equal 3.2 equals gain, our total gain of the system. All right, so that's what we found as our total gain value there. The last bit of this says the linear range, so 7, linear range. And this is just a simple if-then. V0, the absolute value of V0 is greater than or equal to VCC. So that means the absolute value of Vs is less than or equal to 6 over 6.4, which equals 0.94 volts. And that's going to be plus or minus. So that should be set and done. Yeah, that looks good to me too. So that's our linear range then. So that's the amount that it bounces through. So we can look at this and say plus or minus 0.94 volts on a 6 volt op amp. This is good to go. So that was a fun one. Again, let's just circle In red, we've got our voltage divider here as well. That's our third bit. So hopefully the color code helps a little bit to solve this one. That's kind of a fun one.